The third chapter of the syllabus is coordinate geometry. What is coordinate geometry? Coordinate geometry is about dealing with different points on the graph and then its respective graphs taken further in the syllabus. Let's see in brief what coordinate geometry is. But before we discuss about the mathematical concept of understanding coordinate geometry, let's apply a real-life situation in understanding coordinate geometry more better. Connecting with real life to understand coordinate geometry more better. So coming to the introduction, what was the need for the mathematicians to come into researching on the existence of coordinate geometry? Or what was the need for introducing coordinate geometry into the branch of mathematics is the biggest question which need to be opened through this opening problem. So let's see the real life situation. For example, I assume this to be a sea. I have the sea, the whole of the sea, in which there's a ship which is sailing by out here. So here is the ship which is sailing by, and the person inside the ship would like to reach to the bank in the nearest position. So his destination to reach to the bank, which is out here, would be just based on coordinate geometry. Interestingly, this is a real life situation which demands for coordinate geometry. So let's see how he estimates the bank through application of coordinate geometry. The ship out here in the sea is assumed to be 2 units, 1, 2, and 3 units. A person standing here would like to see the distance moving 2 units towards this side, and then exactly when the ship moves to this place, then from here the ship needs to move 1 unit down, is how we understand the distance being measured. So the person who is 2 units left and 1 unit down is where he reaches the bank in the destination. So let's see how this is possible more briefly through the graph. So I assume a graph. I assume x and y axis intersecting at origin, and I assume the ship is at the origin initially in the sea, assumed in the sea. Now his destination to reach at point P is identified through coordinate geometry. A person standing here in the ship in the sea would move 2 units, 1 and 2, 1 and 2 units to the left, and then he would move 1 unit down. Is how we understand the opening problem. So a ship which moves 2 units left and 1 unit down, or 1 unit towards south, where we take the direction as east, west, north, south. So I assume through direction that this ship is moving 2 units towards west and 1 unit towards south. Then he reaches the destination of the bank, indicates on the graph that he is moving 2 units to the left of x-axis and then 1 unit down of y-axis, and then he reaches the destination P. So how do we define P in the graph is the biggest question which connects coordinate geometry with real life situation like this. So when I see the ship moving 2 units left, I see that he is moving negative 2 units to the left, and then when the ship moves 1 unit to the south, I see that the ship moves 1 unit towards P. So I locate this point P with x moving 2 units minus 2 units, that is to the left, and then the point P which moves 1 unit down, and therefore this would be -1 and this would be minus 2, because the negative values come on the negative side of x-axis. On the left we have negative x values, on the right we have negative y values, and therefore we have the coordinates of P which come out to be minus 2, minus 1. The ship destination to reach to the bank is when it moves to the point minus 2, minus 1, assumed through origin. Is how we connect the real life situation of a ship in the sea to reach to its destination in the bank. There are many such examples other than this through which we understand coordinate geometry more better. An aeroplane moving out with certain distance would reach the airport only by using coordinate geometry. A pilot cannot estimate the airport for landing down without estimation through the perfect coordinate geometry. Is how we apply through real life applications. Many more examples to follow with. Before we enter into understanding coordinate geometry more stronger, let's try to understand the structure of the Cartesian system. What is Cartesian system? A Cartesian system through which we understand the location of points and the graphs and the various other aspects related to the graphs and the points. So let's see in brief how the Cartesian system plays a significant role in the coordinate system or the topic of coordinate geometry. Let's see the Cartesian system. What is Cartesian system? Cartesian system deals with the two lines initially being perpendicular. First, I have two lines which are assumed to be perpendicular to each other, cutting at 90. And I take the horizontal line denoted by x, or this is called x-axis, and the vertical line assumed to be called y, or the y-axis. So the horizontal line in the Cartesian system is referred as x-axis, and the vertical line in the coordinate system is referred as y-axis. It's a rule of the coordinate system. They intersect at one point, and the two lines perpendicular and intersecting at point is referred as origin, generally denoted by this, and this is referred as origin, because it is from where we try to take all the different situations, just like in the ship in the previous example problem, where the ship was assumed to be on the fixed base, that is origin. From where we can identify the comparison of origin with the rest of the points. So the intersection of the vertical axis and the horizontal axis is called the origin. The horizontal axis being called x-axis and the vertical axis being called y-axis, and the point of intersection of those two axes being called origin is the rule of the coordinate system. Let's continue further. Here comes now understanding on what would be the definition for the right side of the origin, and what would be the definition on the left side of origin, and what would be the definition up the origin and down the origin. So each of the four directions have their own definitions as a rule of the coordinate or the Cartesian system. Therefore, I have to define the right side of x-axis, which is positive x-axis. Like I take all the values on the right, which are denoted by 1, 2, 3, 4, 5, 6, and 7, etc. It goes on and on till infinity. And the left side of x-axis is denoted by negative values, negative real numbers like -1, -2, -3, -4, -5, so on and so forth. Similarly, all the values on the positive side of y-axis are defined as 1, 2, 3, 4, 5, etc. And this is called -1, -2, -3, -4, -5, etc. Therefore, I have all the values coming on the right as positive x values, negative x values, positive y values and negative y values. Also importantly, it is very important to note that if I refer to this value 3, it indicates my x is 3 at this position. It's nowhere related to y. When I take, say, this value, then I say this point refers to y equals to -4, but this is nowhere related to x. It is independent of x. So this relates to y and this relates to x, is how we understand the values of x on x-axis and the values of y on y-axis. Also, we note that all the numbers on the x-axis on the right side of the x-axis are positive real numbers, and all the values on the left side of the origin on the horizontal axis are all negative real numbers, with origin being the fixed point of intersection of both the axes. Similarly, all the values on y-axis are also the set of positive real numbers, and all the values on the down of y-axis are also set of real numbers which are negative. Positive real numbers, negative real numbers, positive real numbers and negative real numbers is how we understand the coordinate system, the Cartesian system connected with x and y-axis. Origin, x-axis, y-axis are the base rules of the Cartesian system. Now that we have discussed about the Cartesian system, let's try to continue further with the properties and the rules of the Cartesian system. So every point represented on the Cartesian system has its own rules and the respective understanding. So let's see the different rules applied in the Cartesian system. The first of that being the Quadrant Rule. The Quadrant Rule plays a vital role in understanding the Cartesian system subdivided into 4 parts. So let's see how the quadrants gets connected with the Cartesian system in its own respective rules. Quadrants. Let's revisit the Cartesian system of the horizontal axis, which is x-axis, and the vertical axis, which is y-axis, back again from the previous session. As I take my x and y axis, x dash is my x axis and my y dash is my y axis, which intersects at origin, and all the positive side has positive x values, and here negative x values, positive y values and positive negative y values. So my first positive x-axis has all the values coming out from positive real numbers. My negative x-axis has is how I get all the values filled up. Now let's see what each of the rules says. I always start from right to the left, that is going in the anti-clockwise direction of the positive x-axis. So I start from here and I go in this direction, then I go in this direction, then I go in this, and then towards this. So I see that when I proceed in the anti-clockwise direction, the whole of the vertical and horizontal axis which are seen out here is dividing the whole of the board. For example, I take this board, these two axes are dividing the board into 4 parts. 1, 2, 3, 4 is how I divide the plane into 4 parts. So here I have the plane the marker board, which is divided into 4 parts, part 1, part 2, part 3, part 4, going in the anti-clockwise direction. So each of the region has its own independent properties. Now Cartesian system rule says that we divide the Cartesian plane or the coordinate system plane, the board, into 4 parts, and each of the part plays a vital role in the topic of coordinate geometry. So this is referred to as first quadrant, and this is referred to as the second quadrant, and this is referred to as the third quadrant, and this is referred to as the fourth quadrant. So there are totally 4 quadrants which the whole plane is subdivided into by the 2 perpendicular lines, x-axis and y-axis. So using this, let's see what each of the quadrant has to play its role in the coordinate system. Now coming to first quadrant, what is its role in the coordinate system or the topic of coordinate geometry? Let's see each of them. When I see the first quadrant, I always see that this is the region which refers to positive x values and positive y values. So I have this x value as positive, usually the point which refers to the x value as positive and the y value as also positive in this region. Secondly, when I go to the second quadrant from the anti-clockwise direction, I clearly see that in this region I have x values which are negative and my y values which are positive. Therefore, my second quadrant, x is negative and y is positive. It's very simple. Similarly, when I go through the third quadrant down here, I see that my x values are negative and my y values are also equally negative as seen in this diagram. So I refer to x being negative and my y equally being negative in the third quadrant. And the last quadrant which lies out here is the fourth quadrant, and in this quadrant clearly when I see through the diagram, I see that my x values are positive and my y values are negative. Therefore, my x is positive and my y is negative. So finally, we see that when I see through each of the quadrants, the region in which x is positive and y is positive is called the first quadrant. And the region in which x is negative and y is positive is called the second quadrant. And the region which refers to x negative and y negative, that region is called the third quadrant. The region in which x is positive and y is negative is called the fourth quadrant in the branch of coordinate geometry, in the coordinate system rules and regulations. Now that we have discussed about quadrants, the 4 types of quadrants in the coordinate system or the Cartesian system, let's see how we can just use its significance in real life. But before that, it's very important to identify that how we locate the point in the quadrants is what is the biggest question in coordinate geometry. So before we understand the real life situation, let's get into the coordinate system in which the points are located. So quadrant and the rules of locating of a point is what is the session for today. Locating a point using quadrants is what we deal with once the topic of quadrants is learnt. So now that we know the rules of each of the quadrants, quadrant 1, quadrant 2, quadrant 3 and quadrant 4, Next comes on how we can locate through their own respective definitions. So let's revisit the quadrants which we have learned in the previous session to understand the locating of a point. So let's see how we can locate a point. Now when it comes to x and y axis, and this, now let's try to locate some points on x and y axis positively, negatively on either sides of the origin. So here I have the positive x values as discussed, and let's locate them with 0, 1, 2, 3, 4, 5, 6 and so on and so forth. Negative 1, negative 2, negative 3 and etc. Here lies 1, 2, 3, 4, 5, minus 1, minus 2, minus 4, minus 5, etc. So I have each of the x values on x and y axis as we have already discussed in the previous session. Now let's see how we can locate a point in the respective quadrants. As we have discussed, the first quadrant denoted by Q1 lies in this region, and the second quadrant denoted by Q2 lies in this region, and the third quadrant denoted by Q3 lies in this region, and the fourth quadrant denoted by Q4 lies in this region. So each of the denotions of Q1, Q2, Q3 and Q4, let's see how we can locate a point in its respective quadrant. So for example, I have the point generally denoted by x, y. So before we enter into locating a point, let's recap on how the notation is done for a point. What is the rule for locating or denoting a point with the symbols? So when I take the point P, generally I denote with the open brackets with x, y, where x refers to the first value or the x coordinate, that is a value on the x-axis, and y refers to the y coordinate or the value on y-axis. So here I have this value which lies on x-axis, and here I have the value which lies on y-axis. Is how the rule is applied for the point. The point generally denoted by x, y. So for example, I have the point as minus 3, 2. For example, I take P as minus 3, 2. Then this clearly indicates that this is the x coordinate and this is the y coordinate. So for example problem, minus 3 is the x coordinate and 2 is the y coordinate. And minus 3, so x coordinate here is minus 3 and the y coordinate here is 2. Therefore, my x coordinate is minus 3 and my y coordinate is 2. As we know that the x coordinate is negative in this example problem, clearly I understand that it being negative, x value lies on the left of the origin. So I have the x coordinate. Usually each of this represents 1 unit. Each of the distance represents 1 unit, and therefore I break every x-axis into 1 unit subdivided part, and equally the y unit also is divided into 1 unit subdivided part, which indicates that minus 3 refers to the minus 3 units on the left side. The negative sign indicates on the left. So with the x values being on the negative side, I have 1, 2, 3. I move 3 units to the left, and therefore my point P is said to be initially with x value out here, and then my y coordinate being equal to 2 indicates that this is the positive y value, which clearly can be identified in this quadrant as the positive y value, which is 2 units up. So I move 2 units up, but I don't move from origin because first it moves through x-axis and then it moves through y-axis. So a point P moves first 3 units left and then moves 2 units up. This is where finally the point P moves. So when I locate the point minus 3, 2, I understand that it moves 3 units left and 2 units up. And finally, I see that this point P is now in the second quadrant. So the point P, which is minus 3, 2, lies in the second quadrant, is how we locate the point in each of the quadrants using the definition of quadrant concept. Quadrants and locating a point are very much connected through this example problem. Now let's take another example problem to understand the concept more stronger. Let's take an example in which my question says, locate the position of the point A equals two comma minus 5 by 2 in the Cartesian system. So my question out here is, locate the position of the point 2 comma minus 5 by 2 in the Cartesian system. So let's see how we can locate the point using the rules of the Cartesian system. The first thing what I do before I locate the point is, of course, construct the Cartesian system, the base for locating the point, the base for identifying its quadrants. So let's construct the Cartesian system. Intersection of horizontal axis and vertical axis is what is called Cartesian system. Intersects at origin, this is x-axis and this is y-axis. And then let me take some points out here. I have the negative y values. In this manner. Now comes the question on how to locate the point. So let's get back to the point A, which is given to be 2 and minus 5 by 2. As clearly seen that this region is called the quadrant number 1 and this region is called the quadrant number 2 and this region is called quadrant 3 and this region is called quadrant 4 in the anti-clockwise direction, Q1, Q2, Q3 and Q4. Now with this, we also know that the first value of the given point refers to x coordinate and the second value refers to the y coordinate. So here my x coordinate is 2 and my y coordinate is minus 5 by 2, which is in decimal form as negative 2.5. Converting to the decimal form, minus 2.5 is my y coordinate, 2 is my x coordinate. Now comes in locating this point in the Cartesian system. So as I see here, I see that this point is x coordinate, which is positive, and this is 2 units, which makes me understand that the origin moves 2 units to the right initially, and then it moves towards y coordinate with a distance of negative 2.5 units. So here I have this point which moves 1, 2, 2.5. So I exactly have this point moving negative 2.5. Oh, this would be in the down. So I have this to be moving 1, 2, 2.5. So I have this exactly moving at negative 2.5. Therefore, I have my point which is now located at this. My point A is out here, which is 2 comma minus 5 by 2 or minus 2.5. So the point A is identified in the Cartesian system to be in the 4th quadrant. Using the rules of the Cartesian system, we can locate any point. This point being in the 4th quadrant. Any point in xy coordinate system can be located using the rules of the Cartesian system. Next, now that we have discussed about locating of a point in the Cartesian system with respect to its quadrants, let's see an exceptional case of an origin. Origin is also referred as a point, but which quadrant does origin lie is the biggest question. So let's try to take in brief the origin, locating the origin in the Cartesian system. As we know that origin is the point of intersection of the horizontal and the vertical axis. I have this axis as xx dash and yy dash, which intersect at this point, and this is the point which refers to origin, denoted by O. So generally, the coordinates for origin are also equally important because this point also lies in the Cartesian system. It lies in the plane at some position. So what are its coordinates? What is its x coordinate and what is its y coordinate is the biggest question in the branch of Cartesian system. So what is origin? Origin in general English context dictionary refers to the source or the root cause of the source. So here we define origin as the root cause of defining all the points in the marker board or in this plane. So the source of or the root cause of defining all the points is origin, and therefore we refer to this as the initial point. So origin is referred as the initial point of Cartesian system. Now, because it is initial point of Cartesian system, it is understood to have been without moving any units right or left or up and down. It is initially at the point where the x coordinate is assumed to be 0 and the y coordinate also is assumed to be 0. Is how we understand the origin as connected with the Cartesian system. Origin in the branch of mathematics is the root cause, the initial point in the Cartesian system, and its coordinates are 0, 0. We denote origin by capital O and its coordinates being 0, 0 is how we define origin in the branch of mathematics. Now the question comes, where does origin lie? Which quadrant does origin lie is the biggest question out here. So as we see here, we have the first quadrant out here. As discussed in previous sessions, I have the quadrant 2, which is here, the quadrant 3 and the quadrant 4, which lie in each of the regions Q1, Q2, Q3 and Q4. Now comes the biggest question on which quadrant is origin. Which quadrant does origin lie? So here comes the question. As we see that it is in its initial position, it is said to have been neither in this region, nor in this region, nor in this, nor in this. Equally, we sometimes assume that origin lies in all the 4 quadrants, or sometimes we say origin doesn't lie in any of the quadrants. So because it is an initial position, we don't count the origin in any of the 4 regions as subdivided out here. Therefore, it's a very important note that origin being the initial point doesn't lie in any of the 4 quadrants Q1, Q2, Q3 and Q4. So here it refers that origin being the initial point doesn't lie in any of the 4 quadrants. It is independent of the 4 quadrants but plays a vital role in the Cartesian system, connected with all the 4 quadrants Q1, Q2, Q3 and Q4. Origin capital O 0, 0 are its coordinates. Now that we have discussed about even the special case of an origin, let's also realize the different types of terminologies used for the x and y coordinates of a point. So as we have discussed about a point in the Cartesian plane, we have discussed about a point P generally being denoted by x, y. That's how we denote for P being x, y. And x refers to the x coordinate, which is also called with the other name called abscissa. X coordinate of the given point is called abscissa and the y coordinate of the given point is called ordinate. Is how the different types of terminologies are used in mathematics to define the point. X coordinate refers abscissa and y coordinate refers to ordinate. So when we take with a recap of the coordinate system, we understand that x dash and y dash taken in the Cartesian plane with origin being the intersection point of the lines. Then it refers that in the first quadrant the abscissa is positive and the ordinate is positive. And in second quadrant the abscissa is negative and the ordinate is positive. In the third quadrant the abscissa is negative and even ordinate, the abscissa being negative and even the ordinate being negative. In the fourth quadrant, abscissa is positive and the ordinate is negative. Is how I understand the abscissa and the ordinates which define the coordinate system with the respective signs. Plus plus for Q1, minus plus for Q2, minus minus for Q3 and plus minus for Q4. Is how we understand the different terminologies referred to x coordinate called abscissa and the y coordinate called the ordinate. So for example, if I take the point P as 2, minus 3 implies my abscissa as 2, that is my x coordinate is 2 and my ordinate is minus 3, that is my y coordinate is minus 3. And overall my point, locating of a point says that my point moves 2 units to the right and minus 3 units down. So this point moves 2 units to the right and 3 units down, and here I have the point minus 3 and here it is 2 and here is the point minus 2, minus 3. The point is now located in the fourth quadrant using the signs of the abscissa and the ordinate. Locating a point through abscissa and ordinate. through an example 2, minus 3. Now that we have discussed about locating a point in various regions of the quadrant 1, quadrant 2, quadrant 3 and quadrant 4, now comes on what would be the position if I would like to locate a point on the horizontal axis or the vertical axis itself. So today's session is about locating a point on the horizontal axis initially. Locating a point on x-axis, the horizontal axis. So let's recap with the Cartesian plane. Now with the introducing of the Cartesian plane, x dash and y dash, with origin being the intersection, let me just take 1, 2, 3, 4, minus 1, Now I have these points located out here in the Cartesian plane. Now I wanted to locate a point exactly out here. Here lies Q1, here lies Q2, here lies Q3 and here lies Q4. Now here the question is to locate a point P at this region. So how do I locate this point P exactly in between? So I understand that this point is clearly around 2 units from 2.5 units from origin. So I have this to be this resistance being 2.5 units to the right. And now after moving 2.5 units to the right, it doesn't move up or down. That means there's no change in the y coordinate. It is 0 itself from the initial position. So my initial point, which is moving 2.5 units to the right, makes me understand that my point P moves 2.5 units to the right and doesn't move anywhere down. So I have my 2.5 which comes out here as 2.5, 0. So the point which moves towards right on x-axis is 2.5, 0. So I could identify the coordinates of P as 2.5, 0. Let's take another point as a review exercise. For example, I take this point minus 3 and let's see the point minus 3 on x-axis. How do we locate this point and what are its respective coordinates? I clearly see that this point minus 3 is minus 3 units or 3 units to the left, and therefore this has, say, the point Q out here is nothing but minus 3, 0, because this moves along x-axis but there's no change up and down. So this doesn't have its y affected as in the previous case. Only the x coordinate gets affected. Therefore, for point Q, the abscissa is minus 3 and the ordinate is 0. So what do we understand from seeing these two coordinates? What is the learning outcome? Clearly, we see that if we just try with another coordinate, say, let me take out here as R, then clearly I see that the coordinates of R are 1 unit to the right, no change in y, therefore 1 unit to the right, so plus, and then no change in y is what we observe. So what do we observe as the learning outcome in all these 3 coordinates is the biggest question out here. When we investigate the points P, Q and R on x-axis, we see that the point P is 2.5, 0, point Q is minus 3, 0 and point R is 1, 0. We clearly see that each of the points have their y coordinates as 0 because any point on x-axis, there's no change in y, but there's a change in x. So any point on x-axis, there is a change in x, but there's no change in y. Therefore, my note is every ordinate of a point on x-axis is always zero. So this is the learning outcome in case of any point on x-axis. Every ordinate or every y coordinate of a point on x-axis is 0. So any general point you take on x-axis would be in the form x, 0 for all x belonging to the real numbers on x-axis is what we learn as the learning outcome. Any point on x-axis is in the form x, 0. Now that we have discussed about locating a point on x-axis, the next question comes on what is the position when I locate the point on y-axis. When I locate the point on y-axis, let's see the investigation on how its coordinates change respectively, as in the case of x-axis. So let's revisit the Cartesian plane. Imagine the Cartesian plane x dash and y dash with each of the points taken in this form. Now with this coordinate system, let's see any point I pick on the y-axis. Say for example, I have this point P located at this position at 4. So let's see what would be the coordinates of this point P located at 4. Clearly, when I see this point P along x-axis, I see that this point starting from its initial position does not change along x-axis. It directly jumps up 4 units towards y-axis. So this clearly makes me understand that there's no change in x, but there is a change with a jump of 4 units up in y-axis. Therefore, I see that the coordinates of P, which jump 4 units to the top with no change in x, clearly makes me understand that its x coordinate does not change, so its initial point, which is 0, remains the same. It's only its y coordinate being changed jumps 4 units up to the positive side, and hence it affects with 4 units out there. Is how we understand the coordinates of P being 0, 4 out here. Let's try with another example. So for example, I have a point out here which is denoted by Q. Let's see the coordinates of Q. Now as I see the coordinates of Q, as in the case of P, clearly I see that Q jumps 2 units down, and therefore without affecting the value of x remaining 0, the y gets affected by moving 2 units down to the negative side, and hence my Q is this. Let's investigate with one more example. Say I take this to be R. Let's see the coordinates of R. My R coordinates does not affect with x, as in the case of P and Q, and hence x remains same, and then my y coordinate jumps 5 units to the top, so the positive 5 comes into the y coordinate. is how I get the abscissa and the ordinate for each of the points P, Q and R. Now comes the question, what is the outcome of this investigation? As clearly we see that in each of the outcome, the x coordinate is 0 and the y coordinates change accordingly with the position or the locating of the point. So each of the x coordinates being 0 implies that for every point on y axis, the abscissa will be 0, unlike the x axis. So here I note every abscissa on the y axis is equal to 0 is how I make the outcome. Every abscissa on the y axis must be 0. Just like for x axis, every ordinate on the x axis is 0 and every abscissa on the y axis must be 0. It cannot change because any point on y axis changes doesn't affect the change in y. Any point moving along x axis doesn't change the effect of y, and hence for x axis y coordinate is 0 and for y axis x coordinate is 0 is how we understand through the applications. An example problem connected with the points on y axis and x axis. Now that we have discussed about coordinates in the Cartesian plane with each of abscissa and ordinate defined on each of the location of the position on x-axis, y-axis, origin or in any of the 4 quadrants, now comes in applying the situation in real life. So let's see how we can apply the coordinate system or locating of a point in real life using the concepts we have learnt. Let's take an interesting real life problem. For example, my question here says, locate the possible positions of horse in the game of chessboard. So here my question is about locating the possible positions of horse. The horse in the chess game is applied through the rules of the game. So we all know how the horse moves in the chessboard. So my question out here is to locate the possible positions of horse in the game of chessboard. So let's see how we can locate the various positions as assumed with the horse on the origin. So let's try to use this in real life connected with Cartesian plane system. So let's see how we can locate through the graphical xy coordinate system. Assuming this plane to be the chessboard, this being the center of the chessboard, and let's assume that the horse is out here. Let me assume that the horse is out here. Now here, let's take the values on x-axis as 1, 2, 3, 4, etc. And here comes -1, -2, etc. So with this coordinate system, now comes the assumption that the horse is assumed to be in its initial position, that is at origin. So with the horse being on the initial position, I had to locate the possible positions of horse in the game of chessboard. Before we enter into solving this problem, let's try to understand the rule of the horse in the chessboard. We know that a horse in the chessboard moves with the rule 2 units right or 2 units left or 2 units down or 2 units up, and then moves 1 unit next. So if the horse moves 2 units right, it can either move 1 unit up or it can move 1 unit down. Is how we locate. If the horse moves 2 units left, then the horse can either move 1 unit up or it can move 1 unit down. If the horse moves 2 units up, it can move either 1 unit right or 1 unit left. If the horse moves 2 units down, it can move 1 unit left or 1 unit right. Is how we understand the different positions of horse. So with this, let's see how we can apply this in the situation. So initially I have the horse moving 2 units to the right and 1 unit up. So my first position out here is this P, which is located here. So my position P initially is when the horse moves 2 units right and 1 unit up. And therefore, my coordinates would be positive side of 2 and positive side of y. So this is one of the coordinate which I identify of the movement of horse. Similarly, the horse can also move 2 units right and 1 unit down, and therefore I have the second chances of P1, the P2 being it moves 2 units to the right and 1 unit down, and therefore this moves positively 2 units right but negative 1. Because it moves 1 unit down, it moves to the negative side of y-axis, and hence coordinates are this. Similarly, my P3 is when the horse moves 2 units left and 1 unit up. The horse moves 2 units left and 1 unit up, and this comes out to be -2 and 1. Coming to P4, the horse moves 2 units left and then 1 unit down. So it moves 1 unit down, and I get this to be -2, -1. Similarly, I have the 4 other cases where the horse moves 2 units up and 1 unit right. So I have this P5 which locates to moving 2 units up and 1 unit right. So let's see how the coordinates move along these 2 cases. Now that these 2 cases are given by these 4 coordinates, these 2 cases are given by the next 4 coordinates.